to our college forensic science course, Introductory to Forensic Science. Now we're looking at chapter Criminalistics, an Introduction to Forensic Science. This chapter will cover crime scene reconstruction, mainly bloodstain pattern and analysis. Crime scene reconstruction. Crime scene reconstruction is the method used to support a likely sequence of events by the observation and evaluation of physical evidence, as well as statements made by those involved with the incident. Crime scene reconstruction relies on the combined efforts of medical examiners, criminalists, and law enforcement personnel to recover physical evidence and to sort out the events surrounding the occurrence of a crime. Crime scene reconstruction. A crime scene investigator can bring special skills to the reconstruction of events that occurred during the commission of a crime. For example, a laser beam is used to determine the search area for the position of a shooter who has fired a bullet through a window or wound of a victim. Figure 4.1. A laser beam is used to determine the search area for the position of a shooter who has fired a bullet through a window and wounded a victim, showing essentially reverse tracing where the origin of that bullet. General bloodstain features. Bloodstain patterns deposited on floors, walls, bedding, and other relevant objects can provide valuable insights into events that occurred during the commission of a violent crime. The location, distribution, and appearance of bloodstains and spatters may be useful for interpreting and reconstructing the events that produced the bleeding. General bloodstain features. Bloodstain patterns interpretation may uncover the direction from which blood originated, the angle at which a blood droplet struck a surface, the location of a position of a victim at the time a bloody wound was inflicted, the movement of a bleeding individual, the movement number and blows that struck a bleeding victim, the approximate location of an individual delivering blows that produced a blood-stained pattern. Effects of surface texture. Surface texture and the stain's shape, size, and location must be considered when determining a bloodstain's direction, dropping distance, and angle of impact. Surface texture is of paramount importance. In general, the hardest and less porous the surface, the less spatter. Bloodstain from a single drop. A blood that struck a glass surface after falling 24 inches. A bloodstain from a single drop of blood that struck a cotton muslin sheet after falling 24 inches. Direction and angle of impact. The pointed end of a bloodstain always faces its direction of travel. The impact angle of blood on a flat surface can be determined by measuring the degree of circular distortion. Blood dripping at a right angle to the floor surface produces a circular drop. As the angle decreases, the stain becomes elongated. Bloodstain patterns produced by drops of blood that were traveling from right to left. To determine the angle of impact, calculate the stain's length to width ratio and apply the following formula. The sine of the angle of impact is equivalent to the width of a bloodstain divided by the length of the bloodstain. Impact splatter occurs when an object strikes liquid blood. Forward spatter is projected outward and away from the source when a projectile creates an exit wound. Backsplatter, blowback splatter, is projected backward from the source when a projectile creates an entrance wound. Classifying impact pattern. In the past, bloodstain analysis used to determine the droplet size of a bloodstain pattern to classify impact patterns by velocity. The classifications of impact splatter as low, medium, and high velocity cannot illuminate the specific events that produce the stain pattern. In general, the use stain size categories vary cautiously and for descriptive purposes only in evaluating impact spatter patterns. Area convergence. The area convergence is the point on a two-dimensional plane from which the drops in an impact pattern originated. This can be established by drawing straight lines through the long axis of several individual bloodstains, following the line of their tails. Here's an illustration of a stain coverage. Convergence represents the area from which the stains emanated or were flung out from. Area of origin. The area of origin of an impact bloodstain pattern is the area of a three-dimensional space from which the blood was projected. This will show the position of the victim or suspect in space when the stain-producing event took place. The string method is commonly used as a crime scene to approximate the position of the area of origin using found angles of impact of individual stains in the pattern. Gunshot spatter. Gunshot spatter is fine forward spatter from an exit wound and back spatter from an entrance wound. The gunshot produces only back spatter if the bullet does not exit the body. Drawback effect. Depending upon the distance from the victim that the gun was discharged, some back spatter may strike the gunman and enter the gun muzzle. Cast-off spatter. A cast-off pattern is created when a blood-covered object flings blood in an arc onto a nearby surface. This kind of pattern commonly produced by a bloody fist or weapon between delivering blows. The features of the cast-off pattern are affected by the size of the object, the amount of blood, and the direction the object was moving. By counting and pairing forward and backward patterns, one may determine the minimum number of blows delivered. Here we have an example of a swing lower left to upper right. Cast-offs depend entirely on the weapon's ability to acquire and hold blood, how the swing is achieved, and where in space the victim is located for the blows to be struck. Projected pattern. A projected pattern is created when a victim suffers an injury to a main artery or the heart. The pressure of the continuing pumping of blood causes blood to spurt out of the injured area. The site of the initial injury to the artery can be found where the pattern begins with the biggest spurt. The trail away from the point shows the victim's movement. The oxygenated blood spurting from the artery tends to be a brighter red color than blood expelled from the impact wound. A projected pattern found at a crime scene where a victim suffered injury to an artery. Expirated patterns are created by blood that is expelled from the mouth or nose from an internal injury. The presence of bubbles of oxygen in the drying drops or a lighter color as a result of dilution by saliva can differentiate a pattern created by expirated blood. The presence of expirated blood gives an important clue as to the injuries suffered at the events that took place at a crime scene. Void patterns. A void is created when an object blocks the deposition of blood spatter onto a target surface or object, and the spatter is deposited onto the object or person instead. The blank space on the surface or object may give a clue as to the effect and shape of the missing object or person. Voids established the person, the body position of the victim or assailant at the time of the incident. Contact transfer patterns. A contact or transfer pattern is created when an object with blood on it touches the one that does not have blood on it. Simple transfer patterns are produced when the object makes contact with the surface and is removed without any movement of the object. The contact transfer patterns, the size and general shape of the object, may be seen in a simple transfer. Other transfers, known as wipe patterns, may be caused by movement of the bloody object across a surface. For example, this would be a wipe pattern. Flows. Flow patterns are made by drops of large amounts of blood flowing by the pull of gravity. The flow direction may show movements of objects or bodies while the flow was still in progress, or after the blood dried. Interruption of a flow pattern may indicate the sequence and passage of time between the flow and its interruption, such as what is shown. Pools. A pool of blood occurs when blood collects in a level, not slopes, and undisturbed place. Blood that pools on an absorbent surface may be absorbed throughout the surface and diffuse, creating a pattern larger than the original pool. Considering the drying time of a blood pool can yield information about the timing of events that accompanied the incident. Drip trail patterns. A drip trail pattern is a series of drops that are separate from other patterns, formed by blood dripping off of an injury or object. The stains form a line or path usually made by the suspect after injuring, killing the victim, or injuring themselves. The pattern may show direction and speed of movement, lead to a discarded weapon, or provide identification of the suspect by his or her own blood. Documenting bloodstain evidence. Investigators should note, study, and photograph each pattern and drop to accurately record the location of specific patterns and distinguish the stains from which laboratory samples were taken. 2 techniques for documenting bloodstain patterns. The grid method. A grid of squares of known dimensions are set up over the entire pattern. Perimeter ruler method. A rectangular border of rulers is set up around each pattern and a smaller ruler next to each stain. This figure shows the grid method for photographing bloodstains, helping give dimension to each stain. Perimeter ruler method may be used for photographing bloodstain pattern evidence that require a little bit of finagling. In any case, this around the 14.5 minute mark. This includes chapter 4. Glad to have you all in forensic science, and peace.